I have created a puzzle box for somebody as a gift, and perhaps I may revisit one of the puzzles later in my life, improve upon them. So I thought I would record and put it online for, I guess, archive purposes. Um, I guess I'll like wait to give the answer for each one in case there's any viewer that might want to follow along. But anyway, here for the first one, we have a number sequence with the title fill in the blanks. And basically, what you have to do is you see the 4x4 on the left, and you see one on the left that's missing spaces, and you have to figure out what pattern the one on the left does. Pretty straightforward. Definitely the easiest one out of all the sides. I did try to make it get hard as it go along, but I gave up on that later because I'm running out of time. Anyway, for the first one, it's quite easy to see. So if you notice that the two opposing numbers, so for instance 99 and 87, if you take the difference between them, you go and get a very certain number, 12 to be exact, and you can notice the two center numbers 3 and 4 are indeed factors of 12, as well as 6 and 2, which happen to be factors of 12. And also the difference between 41 and 29 is 12, and so on. It kind of goes in a zigzag pattern. And same one for 2791. The difference between them, the factors for that same number is 4 and 16. So you can go and fill in those numbers quite easily with that. Um, and yeah, that's the first puzzle. Going on to the second, we have this one, which I called, let's flip this over. There. This one, which I called Singularity. And we have a couple different similar puzzles. I wrote down a 2x2 and a 3x3, and also looks like we have to fill in the blanks to this. Those instructions up there are just to check your answer. This one I did like some. I just don't like it because I couldn't figure out a way to really just increase the complexity. I could make the same rules happen from the 2x2 to the 3x3, but then if you increase it 4x4, it did not work. But anyway, the way to solve this is that you basically continue the fractal. So you draw a square inside a square inside a square, like such. And what you can do then is you can take the median of the two opposing numbers that are adjacent to the different sides of the square, and then you can go and add it up and get to the middle. And and it works with all of these. So for this, it looks like you might need a lot more information, but you just need to keep going and taking the median in each one until you get to the center. Yeah, if I were to revisit this one, I would try and figure out a way to how to make it expandable. Anyway, on to the next one. Unfortunately, there isn't really a way to follow through this one, but I can still explain it. Basically, you have 6 strips of paper, all with a whole set different sets of numbers, and you just have to weave the grid till it adds up to 157. Quite straightforward puzzle. Hard if you don't think it through, though, I would say. Anyway, moving on to the next puzzle, we have just setting up the ones on top. Anyway, okay, good. Anyway, next one right here, we have a word search. I mean, this is a cool idea, I guess. Not really way make it more complicated than it is. It's pre-finished. So you need a word to move on to the next one. But if you go and search the puzzle and read through it, you'll find that none of the words are uh, 6 letters long, exactly. And if you go and find and all the words, you'll find the words earliest, nano, Fibonacci, Fibonacci three times to be exact, big, enormous, and ultimata. And you can arrange those words from basically describing the thing that's the smallest or the earliest to the latest or biggest. And once you do that, you can look how there's three Fibonacci's, place also Fibonacci in the third place because there's three of them. And if you take the letter in order of the sequence, you go and get a word. And you can go and enter that word in to continue. The word's enigma made it, a bit, I don't know, it's a puzzle enigma, whatever. And moving on to the next. This one I'm definitely the least proud of because I was running out of time and I basically just stopped it altogether because I didn't want to waste any more time. Don't even focus on this. I guess I'll show this part because it's an idea. If you take a look at this for a while, you'll see that the squares that are adjacent to each other flip from even to odd to even to odd to even to odd. All triangles are prime numbers. Down here, all triangles that are adjacent to a square sum up together to become the number in the square. And then as well as the circle being a factor of whatever number it's pointing to. And then I had an idea to make it like a whole lot more complicated, and I mean I kind of did, but I wanted to make this is a lot easier than arguably the first one probably. It's close. I wanted to make it a lot more difficult, but I just couldn't think of anything. Anyway, though, moving on to the final one. Also, originally it wasn't supposed to be instructions like this. It was supposed to be more cryptic, but then again, I got lazy. I wanted to go and just finish this quicker. I might as well explain it. So the first step says for you to find pi and reverse the steps you used to find it. And basically how you do that is you'd go up here to the number grid and you would weave it to find pi and then do the reverse. And you'd get a whole kind of set of numbers. And then I specified reading from left to right, so you know what to select because there's some people who might think if the first numbers are in the grid are from like top to bottom, which I could understand, so I just put left to right. And I wrote that the number of this is the part you can see I skipped. The number of digits can be chosen to be found in triangle, the only twin in the sequence, so that's obviously 11, the prime number, and you just choose the first 11 digits, and then also lazy because I didn't want it was already hard enough, so I felt like it was fine. I just wrote two break, three break, two break, two break, which shows or basically turns the sequence of numbers into coordinates you would see, and then locate the code. And then you go and use those coordinates found on here. You could see on that works like that on the grid, or you could guess that. And then you put in the code, which is youth. And yeah, that's the end of the puzzle. Definitely not my finest, if not my worst work, but I just, uh, I'm just this way today. Can't, tired of a lot of stuff, but I'm just glad I finished it now. Could have taken longer, should have taken sooner, and maybe I could use one of these puzzles later for something, maybe for some passcode.